I got cut off in the last video, we'll just continue on. We were just evaluating these logical expressions here. All right, so let's do this on something a little more complex. In the following, which parts are evaluated? So we have red here, purple, and blue. And go through, remember reading left to right, using parentheses for precedence, and also the logicalness of the or and for connecting Boolean expressions. So how can we make use of this to think about the most efficient way, and by chance the way Python evaluates this, to go through this logical joint statement? Take a moment. Okay. Hopefully you've paused the video if you have not decided. I don't want you to hear the answer before you think through this, okay? So I'm going to go through my evaluation for this. I'm reading left to right, so I start on left. Is 7 bigger than 2? Yes, true. I get to an or. Do I need to evaluate anything on the right-hand side? No, I do not, because it's an or expression. So when I have a true, I know the entire expression is already true. This does not need evaluation. So in the following expression, what gets evaluated? Only the red. We know the whole thing is true by just looking at red and looking at the connector. But let's switch it around. Same test. It's not the same. It's the same components, just switched around. How is that going to change? What gets evaluated? All right, so let's go left to right. Take a moment, make a prediction. Don't just listen to mine, please. It's good for you to make a prediction first. All right, so let's evaluate. 7 bigger than 2. What's that going to be? True. Oh, and notice I have parentheses around this, so we're going to evaluate this expression, then we'll get over here, right? So 7 bigger than 2 is true. I have an and, so I do need to get to this, because if this is false, then this whole thing on the left-hand side of the or is going to be false. So is 9 smaller than 2? No, false. So I have true and false, which gives me false for the whole left-hand side expression here. So then I have a false, and I get to the or. Can I be done? Well, no, because it's an or. If this is a false, then I get a false overall. But if this is a true, then I get a true for the whole expression. So I do have to even get to 8 bigger than 3, which is going to be true. And so I get a true for the whole expression. But what had to be evaluated? Well, first the red, then the purple, and then the blue. So everything, as my grandma would have said, everybody came to the party on this one. So notice, if you're going to try to write efficient code in Python, think about the order of your logical expressions and make use of certain programming structures like the or that connect Boolean tests, because you can be, especially, it's trivial here because these are such easy tests. But if you have complex tests that require extensive calculation, you want to think about that order, don't you? So here we evaluated 1. Here we evaluated 3. So be thinking about how this structure makes a difference on efficiency. Okay, another concept test here. Here we have a function that makes use of a if programming statement, if else programming statement. Here, let's break it down. We're not using our nice form because we do not have our contract. We do not have a test on here, but that's okay. We're going to make use of it and evaluate it, think through the problem. So our function is called isOdd. Our test is if we do this integer division and get a 1, we know the value is odd. Okay, so like 3 integer division 2, we get back the remainder of 1. So then we get true, else false.